All right. So one of the things we can do is if we look at trig equations, where you actually start messing a little bit with what's inside the trig function, so not just the sine of x, the cosine of x, but doing things like 2 times x, or 3 times x, or x divided by 2, or x divided by 4, or something like that. To have these kind of like work and be a little bit more impactful, one thing we're going to do is we're going to restrict the domain. So we're going to look for answers for x values that are only between 0 and 2 pi. And so let's take an example. Let's just sort of get something to work with here. So let's say we have something like the cosine of 2x is equal to negative 1/2. So the whole idea here is that x, our answers, right, for x is 0 to 2 pi. And we're including 0 and we're not including 2 pi, right? 0 and 2 pi have the same position if you rotate all the way around. So if we do hit that sort of 360 position, we're just going to use 0. We're not going to use 2 pi. We're not going to sort of answer twice. So if the x value goes from 0 to 2 pi, well, what's inside the cosine function? What's inside the cosine function is the angle, right, which is 2x. So our angle equals 2x. So if 1x goes from 0 to 2 pi, we can set up like a little inequality, right? So what's going to happen if I do 2 times x? But the actual angle that's going into the cosine function is double that, right? Is double x, 2 times x. Well, 2 times 0 is 0. 2 times 2 pi is 4 pi. So what that means here, right, is my theta is really on 0 to 4 pi. So this is pretty obviously, right, 2 rotations. So I need to sort of look for answers for this equation where what's going into the cosine function could go from 0 to 2 pi or a second rotation around. My original setup here is cosine of 2x, right? Cosine of my angle is equal to negative 1/2. I'm kind of playing a little fast and loose with some of these things. So where is this going to happen? Okay, theta is 2x. So this is going to be 2x is going to hit where? So where does cosine of hit negative 1/2? So that's going to happen at 2 pi over 3, right? In quadrant 2, it's going to happen at quadrant 3. What's that? 4 pi over 3. Quad 1 and quad 4 are not anything, right? So this is our like first rotation, right? Those two angles. So what's happening here is my 2x, 2 times x, goes through 2 rotations. So I also need to include, maybe let's change up my color. So I'm also going to need 2x on the second rotation. So that's going to be same position, right? 2 pi over 3, but plus another 2 pi, right? Plus a whole nother rotation. This would be what, 6 over 3? So that's going to be 8 pi over 3. 2x is also going to be 4 pi over 3 plus 2 pi. So where's that going to send us? 11 over 3? No. Plus 6, 10 over 3. So that's my second rotation. Now, this seems like we've sort of gone off the rails a little bit, right? Because we kind of said specifically I want an x value that only goes from 0 to 2 pi, right? So my x is just doing one rotation around. But if that's x, 2 times x is going to go around twice, right? So once, twice. So that's 2x. So I've got this sort of first rotation version, I've got this second rotation version. So if I lay all this stuff out, right, my solutions here are 2x is equal to, so 2 pi over 3, 4 pi over 3, 8 pi over 3, and 10 pi over 3. Okie doke. Now, I'm looking for solutions that are 1x, right, for a single x. So this is 2 times x. This is my double angle. So that means x itself is just going to be like 1/2 times all of these values, right? So if I want to get to x, I just need to divide everything by 2. So 1/2 times 2 over 3 times 4 over 3 times 8 over 3 times 10 over 3. So what I get is if I sort of find these like double angle answers, I need to sort of account for the second rotation that comes from that, but then to get my final answer I want x's themselves that only go to 2 pi, so I'm going to sort of divide these all down, and what I'll end up with is, so what's going to happen? So this is like, well, everything up top here is an even, I suppose, right? So this is like 2 pi over 3 times 1/2 would be like 1 pi over 3, right? X is 4 pi over 3 times 1/2, so that's going to be like 2 over 3, right? X is 8 pi over 3 times 1/2, that's going to be 4 over 3. X is 10 pi over 3 times 1/2, right? Cancel, cancel. That'll be 5 pi over 3. So my final answer here is going to be x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right, so this is essentially my, what was quadrant 2 and quadrant 3 angles based on 2x going sort of once and then twice around. But when I sort of divide these away, I end up with these like final values here. So kind of tricky, a little bit different, right? There's a little bit of sort of a doubling and then sort of cutting it in half. There's a bunch of different things going on here. Let's take one from the other perspective. Let's do one where we've maybe cut it in half, or let's actually maybe do something where maybe it's by 1/3 instead, just to make it a little more interesting. So how about tangent of x divided by 3 equals +1. So solve for x on 0 to 2 pi. So x does one rotation around. We're looking specifically at tangent where the angle, right, our angle here is x divided by 3. So if I set this up, right, x goes between 0 and 2 pi. If I divide everything here by 3, so that means, well, that's still 0, right? X over 3, this is essentially my angle, right? That's actually going into the tangent function. And then this only goes to 2 pi over 3. Where the heck is 2 pi over 3? So quadrant 2, right? That's going to be somewhere up here. So we're kind of only working in this window. So we're including all of quadrant 1, but we're not including like most of quadrant 2, we're not including any of quadrant 3, and we're not including any of quadrant 4. Tangent is going to be positive in quadrant 1. It would also be positive down here in quadrant 3, but because we're working with now this sort of restricted version, this sort of x over 3, we can only go up to here, which would be like 120 degrees. So the only place this is going to happen, right? So where is tangent equal to 1? So this is going to happen for us where the angle, which is x over 3, what's that? That's going to happen at our 45, which would be pi over 4. And that's it. There's no other value, right? I mean, in theory, if we were sort of doing tangent of just x equals 1, you'd get a quadrant 1 and a quadrant 3 answer. So this is sort of a restriction that actually cuts down on our answer. So if x over 3 is pi over 4, then that means x itself, right? I would sort of take this and I would sort of multiply both sides by 3. So x is going to look like, well, pi over 4 times 3 over 1. So this means x equals 3 pi over 4. So what happens here generically if I double, triple, quadruple the sort of value inside the angle? That will in theory kind of double, triple, quadruple the number of answers I get because I'm doing all those extra rotations. If I do, x divided by 3, x divided by 2, x divided by 10 or something like that, that has the opposite effect. It actually shrinks down the window that I'm working with. I'm working at a much sort of smaller amount of rotation. I could get, maybe, half as many answers, only one answer. I could shrink it down so much I don't have any answers, honestly. At least with this sort of restricted answer region, where the x value can only go between 0 and 2 pi. So that's sort of multiple angles, or in some sense, reduced angles, fractional type angles. And that's all our trig equations. There we go.